1940, and Nazi Germany already controls most of Europe. An isolationist America watches as Hitler's swift and ruthless blitzkrieg war machine strikes at England. The Battle of Britain has begun. The rapid expansion in the Pacific by the Japanese is going unchecked as America continues to object. At Consolidated Aircraft in San Diego, California, the need for the first intercontinental bomber is anticipated. Engineers begin conducting advanced studies, with the first result being the Model 35, a four-engined pusher-tractor configuration. In early 1941, as Hitler continued Operation Sea Lion, the United States military felt England's defenses would begin to crumble under the relentless attacks of the Luftwaffe. It was feared, with Britain captured, Germany and possibly Japan would then attack the United States by sea. Any American bombing attacks on Germany or Japan would require an aircraft to be launched from our mainland. Faced with this scenario, the Army Air Corps issued a directive on 11 April 1941. This directive called for an aircraft that was capable of the following: carry a 10,000-pound bomb load to a target 5,000 miles away, carry a 72,000-pound bomb load over a reduced range, fly at 300 to 400 miles per hour, or take off and land on a 5,000-foot runway. The Boeing Aircraft Company was solicited for the competition. Boeing at the time was building the B-17C bomber for the Army Air Corps. These planes would become legendary during the Allies' air assault on Europe in the coming war. Boeing concluded that no aircraft could be built to meet the outlined specifications and submitted no designs of merit to the competition. Douglas Aircraft would enter the competition unsolicited, based on the giant XB-19 in development since 1936. First flown in June of 1941, the XB-19 with its 212-foot wingspan was later found to be unsuitable for the Air Corps needs. However, many of the systems developed for the huge XB-19 would be employed later in the B-36. The Northrop Corporation of Hawthorne, California, headed by Jack Northrop, seen here in the center between his primary design team members, Walt Cerny and Dr. William Sears, was convinced the next logical step in the evolution of aircraft design lay with the low aerodynamic drag inherent in all wing aircraft. Encouraged by the performance of its N-1M, Northrop Corporation would also enter the competition unsolicited. The only other company solicited for the competition, Consolidated Aircraft of San Diego, California, was producing its PBY Catalina series of aircraft for the U.S. Navy. Like Boeing, Consolidated had also begun production on its legendary bomber aircraft for the coming war. It was the B-24 Liberator. The B-24's long range and large bomb load would enable it to operate successfully in all theaters of the war. 18,482 B-24s would be produced by war's end, more than any bomber in World War II. Consolidated's entry for the competition was a six-engine pusher configuration, still possessing the twin-tail assembly based on the Model 35 first conceived in 1940. Consolidated felt that a pusher configuration allowing for airflow over the wing to be smoother, minimizing aerodynamic drag, would be best suited to achieve the needed range. Consolidated's preliminary design was submitted to Air Materiel Command on 6 October 1941. The arrangement for a contract to purchase 2 aircraft was issued on 15 November 1941. Faced with a massive engineering task, Consolidated began work immediately on the aircraft designated the XB-36. Delivery of the first aircraft was scheduled in 30 months. Simultaneously, the Army Air Force awarded a contract to Northrop Corporation for a single aircraft to be designated the XB-35. Commonly referred to as the flying wing, this radical design is the subject of speculation by aircraft enthusiasts even today. December 7th, and the United States is now at war. The war would soon change priorities at Consolidated. A partial mock-up was constructed in wood at San Diego. The mock-up was approved by Air Materiel Command in September and given top priority due largely to heavy losses by the American fleet in the Pacific. The emphasis was short-lived when America dealt the Japanese their first major defeat at the Battle of Midway in June of 1942. A major delay occurred when the decision was made in August to move the B-36 program to the new government plant in Fort Worth, Texas. This move was prompted by fear of Japanese attacks on the West Coast. By mid-1943, the Allies' air war in Europe was attempting to affect Germany's ability to make war. B-24s and B-17s began concentrating precision daylight bombing raids against Germany's production facilities. This strategy was not without heavy costs to American bombers and lives, as sorties were flown deep into Germany. After repeated heavy losses, the Air Corps would put emphasis on the development of long-range fighters for escort. In the Pacific, the Allies attempted to capture bases within bomber range of the mainland of Japan. At home, war production was at an all-time high. Suppliers hard-pressed by the demands of war production were not inclined to supply custom parts for an aircraft of which an order for only 2 stood. To assist in expediting the desperately needed long-range B-36, Air Materiel Command issued a letter of intent to purchase 100 B-36s in July of 1943. It was hoped that the promise of large-scale production would correct the situation. After extensive testing in the fall of 1943, both Consolidated and Air Materiel Command decided the twin-tail configuration lacked the necessary strength and would have to be redesigned. The introduction of long-range P-51 Mustang fighters in the spring of 1944 would give the Allied bombers the protection needed to fly deep into German territory. The attacks continued to concentrate on oil and manufacturing targets in an attempt to destroy the German war economy. On the Western Front, the Allies landing at the beaches of Normandy on D-Day, June 6th, resulted in the liberation of France. On the Eastern Front, the Russian counterstroke had pushed the Germans back to Warsaw and Budapest by the end of the year. The tide was also turning against the Japanese. America now owned the air and sea as they took back the South Pacific from Japan by leapfrogging from island to island in what would be the bloodiest fighting of the war. In July, the Americans captured the Marianas Islands. These islands would provide a base close enough for the new long-range B-29s of the 21st Bomber Command to attack the mainland of Japan beginning in November. Consolidated was ordered to put full emphasis on production of its long-range B-32 for use in the Marianas.
Appearance of the B-32 Dominator in the Pacific opens a new phase in the super bomber program predicted by General Arnold. First planned as a twin of the B-29 Superfort, the Dominator was redesigned as a more conventional plane without pressurized cabins. An outstanding recognition feature is the huge single fin and rudder. Though slightly smaller than the 29, the 32 carries more armament. This powerful new companion to the B-29 equals the Superfort's range, speed, and destructive potential. These two bomber giants, appearing within a year's time, forecast constantly increasing air blows against the Jap homeland.
Progress on the XB-36 program was once again slowed to meet the demands of war. By early 1945, Germany was on the brink of collapse. Its war economy shattered and its people demoralized. Unconditional surrender came on the 8th of May. The long and bloody war in Europe was over. In the Pacific, B-29s relentlessly attempted to bomb Japan into unconditional surrender. In March, General Curtis LeMay employed the tactic of low-level night area bombing using incendiary bomb. Tokyo burned, but still the Japanese refused to surrender. On the 6th of August, 1945, the B-29 superfortress Enola Gay approached the city of Hiroshima, Japan. Strategic bombing had acquired a new weapon that would forever change the concept of war. Atomic warfare, now a reality, brought a swift close to the war. As Americans celebrated at war's end, the thought of a future war with both sides deploying atomic weapons was a horror that had to be prevented. For the United States, the answer was to create a peacekeeping force so strong that no nation on the face of the earth would dare challenge it. The Strategic Air Command was thus created on 21 March 1946. The newly formed SAC would pay close attention to our wartime allies, the Russians, as they began their expansion by pressuring the buffer states protecting their borders in Europe. Consolidated's contract for the B-32 was terminated. Uncompleted aircraft were destroyed in place, making room for the new program, now a top priority due to its intercontinental range and huge size. The military wanted the threat of delivering the new and bulky atomic bombs to any location inside Russia. By late August 1945, the XB-36 prototype was finally nearing completion. Its huge 230-foot wingspan, 163-foot length, and 4-story-high tail assembly dwarfed the experimental building and its workers. Aircraft number 213570 would soon be rolled out of the Fort Worth plant to meet the public for the first time. The size of the XB-36 was apparent when compared to the B-29, the largest bomber in inventory at that time, but it would still be another year before the XB-36 would fly. On 21 July 1946, taxi tests on the XB-36 began. The Air Force, anxious to see the plane fly, made inspections only from a safety standpoint. On 7 August 1946, taxi tests came to an end late in the afternoon. The next day, after the longest development history of any aircraft to date, the XB-36 with pilot B.A. Erickson and co-pilot G.S. Gus Green made its long-awaited maiden flight.
At Carswell Air Force Base on August 8, 1946, I was privileged to be the test pilot in control of the XB-36 on its initial flight. The aircraft handled very nicely despite its size. There were no worrisome surprises.
The 37-minute wheels-down maiden flight was considered a success. But as testing continued, the program was subject to numerous problems. The primary problems dealt with insufficient engine cooling at high altitudes, excessive propeller vibrations, and a series of electrical failures. A memorable mishap occurred on Test Flight 16 when the retraction cylinder on the right-hand landing gear burst, allowing the 9-foot wheel to swing freely in flight. Erickson and Green were able to successfully land the prototype by steering right and left down the runway after touching down and preventing the gear from collapsing. Severe damage or loss of the prototype would have delayed flight testing by at least a year. The program had already been severely criticized for being 3.5 years behind schedule. The prototype came to rest in the soft earth off the runway, the right side balanced precariously on its huge broken landing gear. Eventually, the problems were corrected, and the test program proved the B-36 to be capable. The first production model, B-36A, serial number 44-92004, with the new raised canopy for better visibility and roller skate landing gears, was delivered to Wright Field for acceptance on 30 August 1947. This was to be the last flight for 004. It was eventually demolished in a series of 45 static and dynamic tests for structural strength. The XB-36 prototype, bearing the buzz number 570, was used to test various systems such as the track landing gear and other variations until 1952. Sadly, the XB-36 ended its career in 1957 at the fire pit of Carswell Air Force Base, used to train firefighters. In late 1946, the B-36 was being criticized for a lack of speed over the target. In 1947, Consolidated proposed reducing the contract from 100 to 95 B-36s to provide the extra funds to develop and produce the C model, using Pratt & Whitney's variable discharge turbine version of the R-4360 engine. The program ran into numerous difficulties, and Air Materiel Command recommended cancellation of the VDT and the B-36C program. With the first B-36A yet to be delivered to SAC, the entire program faced cancellation.
June 1948, Berlin. Ever since the end of the war, 3 years before, tension had been increasing between the Allied military government and the Soviet bosses of East Berlin. 2.5 million people, more than half of Berlin's population, lived in the American, British, and French zones. But the whole city was surrounded by the Soviet zone of Germany. Supplying the 2.5 million people of the western sectors was a system of rails, canals, and roads. Suddenly, the Soviet military government in Berlin clamped down a land blockade of the Allied sectors of the city. They were trying to force the Western Allies to surrender their position in Berlin. And the weapon was hunger. With the fuel supply cut off, there wasn't much electricity. Nearly all of the lights went out.
The only route into Berlin was through the air. With the greatest coordination of men and aircraft in peacetime, the United States and its allies flew in raw materials and food around the clock in an effort to prevent Berlin from collapsing to the Russians. America's commitment in both manpower and aircraft to break the Russian blockade served to underscore for our European allies that America would indeed protect their interests, as we had said after the war. Not coincidentally, on the same day as the blockade began, it was decided to complete the proposed B-36Cs as B models. After 11 months of operating the Berlin airlift, in May of 1949 it was the Russians who capitulated, and the blockade was lifted. The other aircraft considered by the Army Air Corps in 1941, Northrop's XB-35, was not to benefit from the Russian hostilities. Instead, the decision to proceed with the B-36 would lessen that program's chance for survival on the scarce post-war military budget. Despite the program's eventual demise, the Flying Wing is still considered by many to be one of the most significant aircraft designs in history. Northrop's early N-1M designs had proven successful, and the company proceeded with the N-9M1. This one-third scale prototype of the XB-35 first flew on 27 December 1942. It was to crash on 19 May 1943, killing the test pilot. In July 1945, the unfinished XB-35 No. 1 was rolled out of the Hawthorne, California plant. Almost 1 year later, on 25 June 1946, it took to the air. As an effort to save the program, Northrop suggested that 2 of the 13 YB-35s ordered be completed as all-jet versions. The Air Force agreed, and 2 YB-49s were built. The number 1 YB-49 made its maiden flight on 21 October 1947. Early in the program, the YB-49 was found to have an unacceptable rate of yaw oscillation. The Air Force considered it too unstable to be a suitable bombing platform. The YB-49's flying wings had yielded excellent performance results, with top speeds in excess of 500 miles per hour, but were judged inferior to the B-36 in range and payload as a bomber. The Air Force announced the use of the flying wing design for long-range reconnaissance. Designated RB-49As, the Air Force signed a contract for 30 RB-49s. Faced with budget reductions and reports of stability problems, the Flying Wing project was finally canceled on 11 January 1949 in favor of the B-36. With the passing of the Flying Wing, Consolidated Vultee was able to concentrate on the production of the now operational B-36s. The 22A models were in service by November of 1948, with a gross weight of 310,380 pounds. With 24,121 gallons of fuel and 10,000-pound bomb load, tactical range was 3,880 miles. A 72,000-pound bomb load yielded a 2,100-mile tactical range. At a combat weight of 212,800 pounds, top speed was 345 miles per hour at 31,600 feet, with a service ceiling of 39,100 feet. The A models contained no armament, as they were used only for training purposes. SAC's first operational B-36 unit was stationed at Carswell Air Force Base in Fort Worth, located directly across from the Convair plant. By the end of 1948, the SAC unit, the 7th, was joined by the 11th at Carswell. Earlier experience had exposed SAC's need for capable aircraft. The B-36 would help correct this need, but like all new aircraft, it would require a shakedown period to work out problems.
I'd say that probably the first 2 years it was a rather exasperating plane to work on, because you could, particularly I recall the constant speed drives, even though we had initially we had about 3 of them on each airplane. I have actually personally been involved in changing 4 of them before we could get a plane airborne. I think the first 18 aircraft had aluminum wiring in them, and that aluminum wiring, the wind could change from the south to the north and it would break.
They didn't want to cannibalize parts. That was one of the things that early on people would, just to get an airplane going, they would steal a part off of a good airplane. Well, this just doubled your maintenance time, because they'd have to put it back on this other airplane. So cannibalizations were kept to a minimum. If you had to cannibalize, you had to get permission from SAC headquarters, and boy, it better be a good reason to do it.
To address the need for competent crews, SAC embarked on an intensive training program to assure a status of combat readiness.
Here again, the manpower was such that the officer strength was cut back. The navigator and the bombardier positions were filled by a lot of them were former officers that had been re-enlisted as master sergeants or tech sergeants, and instead of given commissions, they were actually flying in those positions. In the early days at Carswell, well, when I first came here in '48, there were quite a few enlisted personnel serving as navigators, bombardiers, and radar operators.
The B models began arriving in July 1949 and contained all armament as specified. The new 3,500 horsepower R-4360-41 Wasp Major increased top speed to 381 miles per hour. The B-36 now earned the distinction as the most heavily armed bomber in history, with 16 remote-controlled 20mm cannons paired in the nose, tail, and in 6 retractable turrets concealed by sliding panels in the fuselage. Gunners manning computing sights in the nose and 6 blisters in the fuselage aimed the defensive firepower. The rear cannons were radar-controlled. The huge bomb bay was capable of carrying up to 86,000 pounds of ordnance in any one of 68 different configurations, including 2 Grand Slam bombs, any of the large atomic weapons of the era, and later the huge air-dropped Mark 17 hydrogen bomb. The large crew of up to 16 was housed in 2 sections of the aircraft. Pilot, engineer, navigator, bombardier, and gunner personnel were housed in the forward section. The aft cabin housed 5 gunners. Once airborne, transversing to the aft section was accomplished via an 85-foot pressurized tunnel. The crew members lying on a cart would pull themselves through the tunnel by grasping an overhead cable to the aft cabin containing bunks, a galley, and other facilities included to make the long missions more tolerable for the crew. One of the B-36's first notable accomplishments was a source of embarrassment for the Air Force.
We took off from Carswell on the 7th of December and headed out for the Hawaiian Islands. We climbed to 25,000 feet just before reaching Hawaii, the main island, the big island, and then turned north to Oahu and Pearl Harbor. At the 5,000-mile mark, we dropped 10,000 pounds of dummy bombs.
To the chagrin of the air defenses at Pearl Harbor, the flight and bomb drop went undetected.
We got no publicity in the States, and my Form 5 still lists the mission as restricted. That's the story.
The latest model of the world's largest bomber, the B-36D, takes to the air on a test run. The 230-foot wing-spread plane, whose fuselage is so long that the 15-man crew must use a scooter to get back and forth, is now powered by 10 engines. 4 jet units, 2 under each wing, have been added to the 6 standard reciprocating motors. The new model has a range of 10,000 miles with a halfway bomb load of 5 tons. The short-range load is 42 tons. It's truly a formidable addition to America's global Air Force.
As Consolidated Vultee and SAC concentrated on fine-tuning the B-36 and its mission, they soon became the center of controversy.
The smoldering feud between the Navy and Air Force bursts into the open before the House Armed Services Committee in Washington. Touching off the battle is Captain John Crommelin, storm center of the controversy, whose sensational charges led Chairman Vinson and his committee to hear testimony by Secretary of the Navy Matthews and Admiral Denfeld, Chief of Naval Operations, that the Air Force, with its atom-carrying B-36 bomber, is trying to displace the Navy in the defense scheme. Prominent among Navy atomic experts is Admiral William Blandy, who tells the committee why each service should have control over its own weapons.
Now, I profess no such degree of technical expertness in aviation as would justify me in either praising or criticizing the particular merits of the B-36 as an airplane. Furthermore, I consider it primarily the province of the Air Force to determine exactly what weapons and devices should be developed and used to carry out its assigned roles and missions, just as the Army and the Navy should determine the weapons and devices needed to execute their mission without being dictated to or outvoted by officers of other services who lack the necessary knowledge and experience to qualify them to resolve such technical problems.
That spring, the Navy's huge aircraft carrier, the USS United States, was canceled in favor of the B-36 to fill the need for long-range atomic striking ability. This infuriated the Navy. The long-simmering debate between the Air Force and Navy was brought to public attention, with the Navy questioning the plane's ability to perform its mission as claimed.
It was saying that the B-36 could not perform its task. My crew was selected to be the one to go to Alaska and fly a profile mission back to the States. We were ferried up in a C-97 and given a couple days rest up there just to sit around and get rested up. But we had our mission drawn up to fly back. And another crew ferried the B-36 up there a couple days later, and it was refueled, and we crawled on board then and flew this mission back. But we took off out of Fairbanks, came down to the coast, followed the coast down to British Columbia, that area, came across to South Dakota, came down to Fort Worth and made our bomb run on Fort Worth, turned around, went back up to the Midwest someplace, and then over to the East Coast to New York, and back to Texas, and flew a round robin. And we ended up flying 33.5-hour mission on that sortie.
In the end, the decision to cancel the carrier was upheld. As the military and Congress fought over budgets, Americans enjoyed the return to normalcy after 3.5 years of war. We were confident in our position as the strongest and richest nation on the face of the earth. But slowly that confidence in the American way of life was being undermined. Americans watched as communism made great strides in both territory and technology. To the shock of the American public, random atmospheric samples taken over the Sea of Japan in September of 1949 revealed the nuclear club had gotten its second member, Russia. 1 month later, in October, China became the People's Republic of China, Communist China. On 25 June 1950, the North Korean communists poured across the 38th parallel into South Korea. In the first days, the North Koreans pushed the United Nations troops south in retreat. Air support was called for. With few strategic targets in North Korea, the bulk of the air war in Korea consisted mostly of support for ground troops. The newer jet fighters proved themselves capable and rugged in combat. The conflict in Korea served to open the coffers for military spending and development of jet aircraft. The B-36 was never deployed to the Korean theater, but remained in its role as SAC's main deterrent against Russia for the duration of the Korean conflict. In November of 1950, the new Pratt & Whitney R-4360-53 engines with 3,800 horsepower were installed on ship number 49-2270. This was designated the first B-36 F model. A total of 58 F models were delivered by the end of 1951. Top speed was 417 miles per hour with a combat-loaded service ceiling of 44,000 feet. 156 H models followed, differing only by electronic updating. Nature, not the Russians, dealt SAC its most damaging blow of the Cold War period. On Labor Day, 1 September 1952, a tornado touched down and ripped across the flight line at Carswell Air Force Base. 71 B-36s were put out of commission, representing almost half of SAC's heavy bomber force. Tom Neely was on the evaluation team to assess damage from the Convair plant.
We came back from our holiday and went to work on Tuesday, found about the storm across the way, and organized a survey crew to go over and assess the damage. We went over on Wednesday and were briefed on the immediate needs to see 10 aircraft that they had previously evaluated, thought they might be returned to service earlier than the remainder of them. The first aircraft that was returned to service 1 week later, and the remainder within 2 weeks. Then we started looking at the severely damaged aircraft, the ones that's components were off and knocked off and were on the ground, outer wings off, fuselage is broken, tails gone. There was more tail damage than any one major damage.
With the help of the Convair plant, 51 planes were back in service by October 5th. 19 of the more severely damaged were towed to Convair to be rebuilt at the factory, with the last being returned to service on 11 May 1953.
One severely damaged aircraft, namely sequence number 242, they had such a severely damaged nose that it would have to be replaced. But instead of replacing it for that purpose, it was turned into the NEBO program and became the airframe to convert it into airborne reactor for the test program.
Only one aircraft, number 49-2051, was not returned to service. It was later employed as a ground test vehicle for an H-bomb test in New Mexico. The last 33 B-36s produced were designated J models. J model wings held an additional 2,770 gallons of fuel, bringing the total to 36,396 gallons. Gross weight was 410,000 pounds. A top speed of 411 miles per hour with a 171,035-pound combat weight was recorded. The last 14 J models were finished as Class 3 featherweights. All unnecessary weight was removed and armament was reduced to only the tail guns to increase speed and range. The last B-36 was delivered to SAC on 14 August 1954. Less than 1 year later, in June of 1955, SAC received its first Boeing B-52. The faster all-jet B-52 series proved to be the eventual replacement for SAC's first intercontinental bomber. In its last years of service, the desirability of the B-36's range was rapidly eclipsed by the desire for speed. In 1956, Convair's B-58 Hustler made its first flight. By the end of the decade, the world's first supersonic bomber would be operational. In October of 1957, America learned Russia had beaten us into space with the launch of Sputnik. This event brought with it the fear of nuclear attack from intercontinental missiles, not intercontinental bombers. The B-36 era would quietly pass into history in 1959. During its service life, the B-36 symbolized the new Strategic Air Command's policy of peace through air power. B-36s and their crews were deployed to all parts of the world to reinforce our intercontinental striking ability. This point was not lost on the Russians and is credited with being America's most persuasive argument against Soviet aggression during the Cold War period. It is easy to see why. The B-36's presence in the world was realized at the hands of SAC. It had emerged from the inheritor of a post-war accumulation of men and equipment to one of the best trained organizations in military history.
You'd go out 2 hours prior to takeoff. You'd have the co-pilot and a couple of the gunners go by in-flight kitchens and pick up the lunches. And while you were flying the 18 hours, there were 3 pilots, 3 navigators, and radar operators. And everyone would take turns of working about 4-hour shifts and 4 hours off. And that way the crew stayed rested. But it turned into a 24-hour day by the time you came back, landed, pre-flighted your equipment, and then debriefed. So you were gone flying and the activity for a 24-hour period. And you'd fly every 10 days.
Crew integrity was one of the prime things that General May stressed at that time. And he had several means of making sure that the crews stayed together, with like the spot promotion, and which was a very important thing to everybody that was involved in it. SAC was the envy of the Air Force at that time. The other commands didn't have it.
As B-36 crews deployed to all parts of the world, Americans at home had become consumed by the Red Menace. If the fear of communist infiltration wasn't enough for the American public, we also became preoccupied with another dark fear.
If the communist bloc does attack, our radar sites and observers will sound the alert. Giant bombers will take to the air. Jet fighters will scream aloft. Fighters will account for some of the enemy, but some will get through to your home.
It's a bomb. Duck and cover. Here's Tony going to his Cub Scout meeting. Tony knows the bomb can explode any time of the year, day or night. Duck and cover. Atta boy, Tony. That flash means act fast.
The Cold War for B-36 crews meant dealing with the probability of nuclear war 24 hours a day.
All select crews, lead crews, and ready crews, which encompassed all of us, were briefed and had targets assigned and had atomic bombs allocated to our aircraft, and the aircraft could be put on alert and held and ready and be off the ground in less than 5 minutes.
Faced with a possible conflict, would have to go to war. We were the ones that would have to really look out for ourselves at home, because and I know this may sound silly today, but back in the early 50s, we would keep our blinds closed at home, because we never knew. We were under the impression that someone could go down the street, take a pot shot at us, and if they could, those were the primary people on the crew, the radar operator and the aircraft commander. If they could do away with either one or both of those, that crew would be ineffective. They'd, wiped out. They wouldn't make the target.
This is an official civil defense warning. This is not a test. The United States...
Thanks in part to SAC's ability to meet its mission, our worst fears never materialized. Throughout its service life, the B-36 was the subject of several modifications and a flying test bed for numerous theories. Its great size and range lent itself to experiments that were not possible in any other aircraft built before or since. The first of the variations was a transport version designated the XC-99. On 31 December 1942, the Army Air Force ordered a prototype cargo plane. Using the same wings, engines, and landing gear as the XB-36, the fuselage was 20 feet 6 inches tall and 182 feet 6 inches long, with a capacity for 100,000 pounds of cargo, or 400 troops. On 24 November 1947, the XC-99 made its maiden flight. Consolidated Vultee proposed a production version utilizing cargo doors fore and aft for the movement of large vehicles. Only the prototype XC-99 would be built. Until retirement in March of 1957, the XC-99 logged 7,400 hours at a lower cost per ton-mile when loaded than any other cargo aircraft. In an attempt to see the B-36 into the jet age, Convair developed a swept-wing all-jet version of the B-36, designated the YB-60. The YB-60 was 175 feet 2 inches long, with a wingspan of 206 feet 5 inches. The YB-60 was powered by 8 Pratt & Whitney XJ57P3 turbojets. The crew requirement was 5 due to a lack of armament. Combat weight of 260,250 pounds netted a top speed of 508 miles per hour at 39,250 feet. 2 YB-60s were constructed without full tactical armament. Over 100 miles per hour slower than the Boeing B-52, the YB-60 was not considered sufficient for production. The most interesting variation of the B-36 was the NB-36H Crusader program. This program was the result of an Air Force contract to develop a nuclear-powered aircraft. The tornado-damaged 51-5712 was modified as the test plane for this program. The Crusader carried a 1-megawatt power reactor aloft in its bomb bay. The reactor was lifted by a shielded crane into a pit and then raised by remote control into the aft bomb bay. A cooling system in the aft fuselage was used to dissipate heat generated by the reactor. A 5-ton shielding plate in the forward end of the aft bomb bay was added for protection of the crew. Once the Crusader was airborne, the nuclear engineer started the reactor by removing the safety rods. Radioactivity was measured throughout the aircraft by instruments in the cabin, while the B-50 escort plane measured the amount of radioactivity released into the atmosphere. Television cameras mounted on the aft exterior fuselage monitored the engines. The crew was unable to see or hear them in the heavily shielded crew compartment. The NB-36H made 47 flights between September 1955 and March 1957. The program proved the infeasibility of nuclear-powered aircraft due to the effects of lingering radiation on the aircraft. The Second World War had taught the need for fighter escort on sorties deep into enemy territory. The B-36's range made the advent of a self-sustaining fighter impossible at that time. Under the project name of FICON, the first attempt was the Parasite fighter, the XF-85, designed by McDonnell Aircraft. Nicknamed the Goblin, the fighter was designed to fit entirely inside the B-36 bomb bay. The plane possessed a compact 6-section tail assembly. With wings extended, the wingspan was 21 feet 1 inch. Folded, the width of the Goblin was only 5 feet 5 inches. The length was only 14 feet 10 inches. Built around a 3,000-pound thrust Westinghouse J-34 WE-22 engine, the Goblin carried approximately 30 minutes of fuel at cruise and 20 minutes at full power. Top speed was 648 miles per hour. On 23 August 1948, the XF-85 first flew, launched from a modified B-29, since the B-36 was not available as yet. Although the aircraft performed up to expectations, the lowering and retrieving of the Parasite by use of the trapeze was found to be extremely difficult. Under combat conditions, it was felt the concept would be virtually useless. The program was terminated after 7 test flights. In January of 1952, tests began on the next attempt in the FICON program. A modified F-84E was to be launched and recovered in flight when needed. In May of 1953, the first successful recovery tests with a modified GRB-36F aircraft, number 49-2707, and an RF-84K led to a contract calling for 10 RB-36s and 25 Republic RF-84Ks to be modified for the program. The selection of RB-36s and RF-84s indicated the Air Force felt this project was more suited to reconnaissance than fighter escort applications. The last and least successful FICON program was the Tom-Tom. This project called for the attaching of an RF-84 to each wingtip of a GRB-36 by means of a special hook. Pilot discomfort on long flights and an accident caused by the intense wingtip vortices canceled the program in late 1953. In 1954, aircraft number 52-2827 was the last B-36 produced. On August 8th, it was the subject of a ceremony marking the end of the program. The festivities also marked the end of an era. The new jet age had been born and was forcing the retirement of the propeller-driven aircraft. In all, 383 B-36s had been produced at an average cost of $3,776,000 each. On 12 February 1959, this last B-36 was again the subject of ceremony as it was flown to Carter Field in Fort Worth, Texas, to be placed on permanent static display. The B-36s had made their last flight by the end of February. The fleet was officially retired and sent to Davis-Monthan in Arizona. They were cannibalized and left to wait in the hot sun of the desert boneyard to be sold for scrap metal. Although saved from the smelter, aircraft 52-2827 sat unattended for several years, the victim of vandalism and neglect. In 1979, the newly formed Southwest Aerospace Museum rescued the plane from the scrap pile. For over a year and a half, volunteers worked on the disassembly and transportation of the plane. Today, this plane is located in White Settlement outside the gates of General Dynamics and adjacent to Carswell Air Force Base where they once served. Work still continues on the complete restoration of this aircraft, one of only 4 left on public display.
And I'm almost certain that most people felt that it was the biggest deterrent going against the Russians at that time, in that it could take off with an atomic bomb and fly for any place in Russia and bomb it and fly back to a neutral country.
All I can say is I've got probably the fondest of memories of that 10-year period of my life. I look back to it, I know everybody worked hard. There was a few that complained about it, but not many, but everybody did work hard. We played hard, and I don't look back to any of the bad parts of it. I look back to the fun we had and the accomplishments that we achieved.
The B-36 stands as a tribute to the thousands of people who designed, tested, and built it. The fulfillment of its mission stands as a tribute to the people who flew and maintained this aircraft during one of the most unsettling times in American history, a time when fear and unrest, not war, shaped the life of the B-36 and the people around it.